Um, Speaking of technologies, there were actually two awards from the Air Force Office of Scientific Research in the past few days that I think are noteworthy. And one of the issues we see in quantum technology is the qubit quality, and we track that quite closely. We have a page on the quantum computing report called Qubit Quality, and we list things like coherence times. And all the companies are working very, very hard in order to make that better. So you need it both for NISC as well as even error corrected. The better the qubits you start with, the easier it is to implement an error correction code. So one award was for $1 million to the University of Illinois to look at the material properties of superconducting qubits and how you deposit them and how you manufacture them to try to eliminate as many defects in the deposition as possible. And by doing so, you will improve the overall qubit quality. So they're going to do a deep analysis of how to do that and maybe come up with some recommendations on how to better manufacture Josephson junctions. And the other was another award to a group of universities. It was led by the University of Rochester for $6.7 million to do a similar thing with a focus on silicon quantum dot, silicon spin qubits. Again, how you manufacture those is critical, and the whole idea of making better and better qubits takes a lot of work. There's a lot of different things involved. How you deposit the materials, what the architecture is, how you control them. So there's a lot of work, but those two awards will certainly help, we think, ultimately let the industry understand how they can make better and better qubits.